Hi everyone, welcome to the Batch Processing API. So today we're gonna check everything about the Batch Processing API, which is our service which you can use to process huge amounts of satellite data. So this can mean either processing very large areas or very long time spans or both of those. So what do you need to actually do the batch processing API to use it? You need 3 prerequisites. Number 1, it is very useful if you have a basic understanding of our process API first. So if you're not familiar with this, check also our process API webinar, which goes into details on this service. The next thing that you need is a Sentinel Hub enterprise account. So you can only use Batch if you have an enterprise account, but don't worry because you can also get a sponsored account by ESA for pre-commercial or research purposes. The link will be at the end of this video. The third thing that you need is an AWS account. You also need the AWS client setup if you want to download data. Why do you need this? You need this setup so that the AWS bucket, the system can know that this bucket has permission, that Sentinel Hub can write to it and read from it. So this is why you have to set up the account and bucket, and we will also check how this is done. So after we check all this, we're going to create a basic batch processing request. And then we're going to check how you can download data from AWS and then import it into QGIS. We will say a couple of words on stitching and how you can make requests in Python and Postman as well. At the end, we will also check how you can make a batch collection, which means that you can create a collection that appears in your dashboard, that you can then create configurations and then make OGC or a process API request to it and also view data in your browser. So this will be done in 2 major parts. So the first one will be a basic batch request, and then the second one will be the batch requests with creating a collection. So before we dive into the technical things, let's check some interesting blogs and examples of the batch processing API. So on our documentation, this is our technical documentation, docs.sentinelhub.com. This is you can find batch processing API technical documentations and also examples. Here you can see you have all the information about tiling grids, the examples, everything that you might need. Here you also have a couple of interesting blogs linked. So let's check some of them out. So this one, how to create your own cloudless mosaics in less than an hour, is going to teach you how you can create a mosaic of a large area so that you don't see clouds using batch processing. It also explains a bit in how batch processing actually works with examples from the request builder. The second example is the basic one, introducing batch processing, where you can see the beautiful Australia that has been processed using batch processing API, which you can also do yourself using this service. So batch processing API is usually used for 2 main purposes, either for creating cloudless mosaics or for uploading data to your own cloud and then using it for machine learning. And for machine learning, you also have an interesting blog post over here, scale up your EOLearn workflow using batch processing API. So it goes into detail in giving you a bit of an idea of how they do this. This is a basic machine learning EOLearn workflow, and then how it looks like when it is combined to batch. So feel free to check this out. We have a lot of our blogs on our Sentinel Hub Medium blog, so you're going to find a lot of interesting blogs there. Okay, so what I would like to show you now is a very cool example of batch that has been made by our team. It is called the Sentinel 2 L2A 120-meter mosaic. So this is actually a full year of Sentinel-2 cloudless data processed, where several bands were processed, so you can even do scripting, and this for the whole world. This is a free collection. If you just click on this, you're going to see the collection ID here on the right. Let's copy this and go to our configurator. Now we're going to create a configuration using this collection, and then we will view it in your browser. Click on New Configuration and name it 100-meter mosaic, for example. And then you're going to see that there exists an actual template for this collection. Sentinel 2 L2A 120-meter mosaic template. Click Create a configuration, and the visualization layer with the scripts are already prepared for you. All you need to do is leave it as bioc, and then replace the collection ID. You need to do this for all the layers, otherwise you are going to get an error in your browser. But this is done very quickly. And when you do this, you will be able to actually view your data. You could, of course, also make process API to this collection if you wanted to. So let's go to your browser now. First, you need to be logged in. And then I will refresh it so that it recognizes that a new configuration has been created. And if it's not, we will go to the incognito mode to avoid cache, but luckily it worked. All right. Now let's visualize it. And when it all loads, you will be able to see all the visualization layers that are prepared in the configuration for the whole world. So the resolution is 120 meters. If you can see, I can zoom out so much that I can see the whole world, but I will not right now because of the long loading. And then I can click on any visualization, such as this one, or maybe the moisture index. And this is absolutely amazing. And I think it is a really great showcase of what Batch can do. If we zoom in, you will see that the resolution is amazing and you can play with this. You can even make custom scripts. If we go to custom, for example, you will see which bands have been processed, and we can create any combination of bands, and we will see our own custom script displayed, as you can see loading over here. So feel free to check this out. You can find it on our collection, sentinelhub.com, where you can also find a lot of other public collections that you can use. All right, let's jump back to our agenda. And I think it is time to actually create a batch request in Request Builder, because it is the easiest way to create a request using an actual user interface. Right, I almost forgot. Before we do this, we have to set up the AWS account and bucket. So this is how the AWS S3 bucket looks like. You will have to create an account, and then you will have to create a bucket. So if we quickly jump to our education page, we have a tutorial over here that can help you greatly with this. It is actually created for the Card4L tool, which is a separate tool that uses batch processing to bring you Card4L compliant Sentinel-1 data. We have a user guide over here for this tool, but this user guide can be easily used to show you step-by-step, very in detail, how to create your bucket and how to configure AWS client. If we just scroll down a bit, you will see personal bucket over here. So you will see that you have to create on this orange create bucket. If we jump to the S3, you can see it right here on the right. And then when you click this, you will name it. In my S3 bucket, you can see all the buckets that I have here. We will be using this one, which is named Batchmonia. In this case, you can name it anything you like. When you name it, you will set the region to be EU Central 1. This is a requirement for Batch. And then when this is done, you will click on permissions, edit, and you will paste in the code for setting up the policy for your bucket, which is going to allow Sentinel Hub to read and write from this bucket. On our documentation, if you jump to AWS S3 bucket settings, you will see the bucket regions that you need to set and the code that you have to paste in. So this is where you can find it. Then when you're done, you save, and this is it, your bucket is created. The next thing that you need to do is in the same tutorial, in chapter 7.1, install and configure AWS client for data access. First, you will install the AWS client by following this tutorial. And then what you will do, you will follow the guide for finding your credentials. And to do this, you will go on the top. Let me zoom in a bit. You will go to the top to your account, say my security credentials, click on access keys and get your access key. This is going to give you a file which will contain your access key and secret. Then you will just write AWS configure into your command prompt, and this is going to, after of course having it installed, and this is going to bring up this code which will ask you write in the access key, write in the secret. And when this is all done, your AWS is configured and you will be able to download data. This, of course, you only need if you want to actually download data to your computer, but you need a bucket setup to do batch in any case. All right, so we are now set. Let's start with our batch request. So as you can see, this the request is very similar to the processing request that you are already familiar with. If not, check the webinar. Up here we have the, we can set the collection for the batch. You can see which ones are supported, the time range, the location, and we're going to select Krita over here. And as you can see, this is a huge area of 32,000 square kilometers. And then you have the eval script and of course the request. So the request here, you can see the preview for different kinds of requests that are batch related. You will see what create, analyze, start, cancel, and all that means very shortly. Then when you scroll down, you actually get your actual batch settings. So the first one is tiling grid. So what is the tiling grid? Well, tiling grid is the grid covering the world, which sets how your tiles are going to look like. So the grids can be 20 kilometer, 10 kilometer, 100 kilometer, which means that 100 kilometer grid that each tile is 100 kilometer large. And then you can also set resolution. So each of them has a specific resolution. So the 20 kilometer grid, as you can see, has 10, 20, and 60 meter resolution. And the 100 kilometer one has 60, 120 to 140, and so on. Let me just quickly show you how this looks like in QGIS. So in QGIS, you can see that we have imported the 20 kilometer tile grid into over the Krita region. And then we added a couple of tiles with the Krita process. And you can see that it is a perfect match. Each tile matches perfectly the grid tile. And as you can see where they overlap, this is because the UTM is used. On the left, you can see how it looks like when the whole grid is processed and put into the QGIS, perfectly covering the grid. So if we had a 100 kilometer grid, then our tiles would look different. And of course, they would again be perfectly covering the grid. All right, so we're going to set the 20 kilometer resolution. Let's select the 60 kilometer actually. It will be big enough. And then the bucket name. Here you have to write the name of the bucket that you selected. I will just grab Batchmonia and paste it in. And then here we have a tile path. So tile path is very important because it makes some things easier for you. If you have a lot of tiles, especially if you have various outputs, this can get complicated. So if you leave it at default, let me show you what is going to happen. The tiles are going to be input into an actual, just an ID name of your request, such as you see this one over here. And when you click on it, each tile is going to be in its own folder. And then you see a TIFF inside. So this depends on what you need. But if you would want, for example, to download this data, then grab all the TIFFs and put them into QGIS, this would be quite annoying because you would have to open each folder up by yourself and then pull each TIFF out and so on. So this is why you can actually manipulate the tile path. And in our documentation, if you go to API reference down below, you can click on batch. And then you can see the output. And here you have the information on the default tile path. You can read about this. You can use the several different placeholders to manipulate the path of your tiles. So for example, you could say a tile name.tiff, and then all the tiffs would go in the folder specified before that. Note that these are actual placeholders. You cannot replace what is written inside here with anything else, because specifically saying tile name will tell the system that you in fact want the tiles to be listed over here. So let's jump back to the request builder and let's specify the path. For example, create / tile name and then tiff. This is going to create a folder create and then list all the tiles inside that folder. So we can see this on the bucket. For example, here I have the folder name create RGB. and all tips are listed inside. So this is much more handy if you would like to just download data and view all your tips at once. What I forgot to mention in our documentation, tiling grids, you can also download them. This is how I got it into QGIS and read all about them. Okay, let's see what are the other settings that we can set. So here is a description. The description is going to be something that is then stored in your request so that you can find it easier. For example, create RGB, webinar July, why not? And then you can also specify if you want COG output. If you enable this, you will get advanced COG parameters, such as overview layers, minimum size, block size, and so on. And you can read about it. So this is connected to GDAL and GDALado settings. You can also select create collection, which we will take a look at a bit later. Right now, we are not creating a collection. So using this request, you will not be able to create to make a configuration and such, but you will be able to download the data. Collection ID, you could now also insert this, the collection, the ID of the existing collection, and add tiles there. Override can also be very useful. If this is enabled, then data, if it already exists on your S3 bucket, it is not going to throw an error, but is going to be overwritten. Now, what is really useful is that you can always get a low resolution preview before you start with running your request so that you can check if everything is as you expected. Here are the settings. It would make sense to keep the ratio so that your image is not skewed. And let's see, for example, that we want a bit larger image. And we can also set the format to be PNG so that we will see it instantly displayed. And now when we click Get Low Resolution Preview, we will see the create image displayed. So if you see, okay, everything works as intended, you can then proceed with the request. So if you're not creating a collection, then it doesn't really matter what kind of output you write in your script. You can copy in any script that you like and it will work. Let's jump to the custom scripts and let's grab this script, the land use visualization with linear discriminant analysis. And we can just copy it and paste it in. And now when we click Get Low Resolution Preview, you will see it updated. You can also download it to view a larger image, as large as you specified in the settings. Let's check the request just quickly. So you can see that the URL is changed. It now has API version 1 batch and then process. Then you can see that most of the request is very similar to the process API request, and the batch parameters are actually down here below. Here we have a tiling grid, an ID of the tiling grid, which is 0 for the 20-kilometer grid resolution. Here is our default tile path, which we specified that COG output is true, and also a description. When you are happy with your request, you can click Create. So clicking Create is not actually going to run the request. It's just going to give you an option so that you can analyze it and see some information. So on request created, the request is now prepared, and you see some information of what you chose. You see the estimation of how many tiles. You see this is 100 tiles. You see the description, the tiling grid, the resolution, and so forth. So now we would click Analyze. But first, what I would like to show you, the analysis is going to tell you if your request is healthy. If there is an error, it is not going to go through. And if analysis is complete, if it goes through, then your request is fine. So for the demonstration purposes, I am now going to go back to the Truecaller, and then I will change, I will create a little typo. And then I will click, actually I will now delete this one and then click Create again and click Analyze. You can see that analysis was successfully started, and this can take a couple of minutes. Here we have to be a bit patient, and if we click refresh, we will see an error. You can see that it tells you where the error is. Analysis failed. You can see failed evaluate script. Samples is not defined. So if we remove this typo, delete this one and create one again, and click Analyze. And then again, wait a couple of seconds so that the analysis actually completes. Click refresh. It is still analyzing. As you can see, the status over here. And now analysis is done. There was no error, and you can see that 105 tiles are pending. You can see that the previous estimation was a bit off. It was 100, and now it is 105. So what is going to happen when we click Start? When we click Start, the batch processing request is actually going to go through, and the processing will begin. You can see how much this would cost. So batch processing is actually, the cost is estimated in processing units. And you can see the approximate estimation of how many this would take over here. It says 15 processing units. How many you have depends on your account. So 105 tiles are pending and 105 tiles are total. When we would click Start, they would move to scheduled and then eventually to processed. When all of them are processed, you will know that your request is actually completed. And also the status will change. It will then, when it is done, it will say done. The tiles can also fail, and you can then restart partial request, which is going to restart the failed tiles if that would happen for some reason. All right, so let's click Start. When we click Start, the request is going to appear under the running request, but we have to click Refresh because it doesn't refresh automatically. And as you can see, it is now in running request, status processing, and you can see that 100 tiles have been scheduled and 5 are pending. Each time you click Refresh, you can check the process, how far your request is at the moment. We're not going to wait for this all to complete because we already have this request processed. And what we're going to do, we're going to now go and download this data from the AWS. So I have the same request over here under the create RGB, and how you can download it after you have your AWS client installed and all that. You jump to a request builder, and then you can see this link down here, which actually syncs the folder that you are in with the S3 bucket, and it downloads the tiles that the folder includes into your computer. Okay, we're now going to download the data. We will jump to request builder, and the request builder, I actually have it already processed. You can see create true color over here, and I will grab this link, go to command prompt, navigate to the folder where I want my tiles. I have it set up like this. This is my folder with tiles that I want. And now I can paste in this link from request builder of any request that I have processed previously, in case I haven't deleted the information from the AWS bucket. And as you can see, the tiles are now downloading. And as soon as it is complete, you can check in your tiles folder that they will all appear, and they are all TIFF files. You can check them out, and you could now all drag them and put them into QGIS if you wanted to. The next thing that you can do is stitch these tiles together into one image. To do this, you can use the special stitching script that is on our GitHub repository. Sentinel have GitHub, code snippets, and you can see the stitching script over here. So what I want to do, I want to navigate to the folder which includes the stitching script and my tiles. In this case, this is this folder. I will copy it, and then I will go to my Anaconda prompt. And I will run the GTL environment. Yeah, so before we continue, let's just check quickly how this is done. All you need to do to use the stitching script is you need to have some kind of a Python environment with GTL installed. So one way to do it, only one, is to install Anaconda and then install this all of these necessities, and then just run the script. You just write the name of the script and then the name of the folder with your tiles. So this is what we are doing right now. We will now navigate to the folder. And now we will just grab the name of the stitching script. And of course, not forget to say sh. And then tiles, which is the name of the folder containing our actual tile images. When we click enter, you can see that the processing has begun and the output is actually created. So this processing, how long it takes depends on how many tiles you have. Batch can easily have 2,800 tiles or more if you are doing it for, let's say, the whole of Great Britain or something like that. But it is, for our Crete, it will be done pretty fast. So we have the complete mosaic over here. And you can see how it looks like. You get the small TIFF, the tiny TIFF, and the full TIFF. And if we open the full TIFF and zoom in, you will see it is in fact in 60-meter resolution. And this is it for the stitching. All right, let's jump back to our agenda. So what we have done now, to sum it up, we have created an AWS account. We have configured the bucket. Then we have prepared a batch request in Request Builder. We have decided that we are not making a batch collection, and we have then stitched tiles and downloaded data. So before we continue with the collection, let us just quickly jump to Python and Postman to see how the requests look like there. So this is batch request in Python. You can actually find batch requests on our Sentinel Hub Git if you go to Sentinel Hub Py on GitHub. You can find the examples over here. And here you have batch processing notebook, which is a lot larger than the one that I'm showing you now. It has so many different examples and everything that you can do with it using the Sentinel Hub Py library. Over here, we do have a simpler example though. So the only thing that we have are a couple of dependencies. And then in a separate config file, we have Sentinel client ID and secret specified. Then we have the authentication setup over here and the health check that if we run and get a response to 100, we know that everything is fine. So in Python, it is similar. You have to do the post batch request first, which is essentially a create in Request Builder. Then you do analysis, which is a request in analysis, as we clicked analysis in Request Builder. And then you also confirm. You have to confirm it, as we did in Request Builder as well. So let's just check it out quickly. The request is a similar request to the process API Python request. And again, here on the bottom, we have our parameters set. Then what we do, we need to set the URL over here, which we checked before that it is batch and then process. And then we just print out the JSON file that you also have in the Request Builder. You can see that the status in this stage was created. You can see all the information about the request, the eval script, the estimated tile count. In this case, it was 34. Then when we run the analysis, we run the request with a different request URL. So at the end of this, we add analyze, and of course, we need to add in the request ID. You can get the request ID somewhere in your response, and you can see it over here, ID, and this is your ID that you would put in here. You would have to put it in every consecutive request after your create request so that it would know which request you are actually referring to. The Request Builder does that for you automatically. If we jump quickly, you can see the request of each ID of each request here on the top. But the Request Builder already pulls it into all of these requests. But if we just scroll up a bit and check, for example, analyze, you can see this request over here, batch request ID, analyze, and the Request Builder just grabbed this ID over here. Now in Python, you have to do this yourself. However, there is a neat trick. You can simply specify the request ID as a variable and then tell Python to check the response JSON for the ID and then read the actual value of that ID, So every time you can then just write in the request ID and it will read the ID from the request itself. All right, so when you write out this analysis request, you will see here the analysis done. And you will also see the value estimate, which is the approximate amount of processing units that this would use. Okay, then when you confirm the request, you have this request again, but instead of analyze, you have start at the end. The request ID again, you would have to replace, but it is just going to read it from the request now. Another thing I forgot, if you do this and then get an error after sending your process request, just comment out this, because then you are actually going to get a nice response. Otherwise, you will just get ID not recognized. Actually, when you click start and you confirm it, it will actually start processing, and you can then use this request ending with tiles to check what is happening with the tiles, and you can see that at time of running this request, all the tiles were pending. So this is it in Python. In our documentation, if you go to examples, they are actually written in Python. So you can say, for example, request detailed analysis, and you can see the same thing over here, how the request looks like. So in our examples on top, we also have a Postman collection. If you click this and then right-click and save as, and then import into Postman, you will be able to actually see the curl requests as well for all of the necessary steps that you need. So create a batch request, analyze, start, cancel as well, get tiling grids, and all of that, get information about your tiles. And if you click on any one of them, you can see how the request actually looks like. And here you also have examples for creating a batch cloudless mosaic collection and then requesting it with a process API. So let us just quickly say what are the differences between not creating a collection and creating a collection. If you do not create a collection, as we have done now, you can download the data, put it into QGIS and so forth, or you can put it to your cloud and do machine learning analysis to it. But if you do create a collection, then you need to be careful about a couple of things. You will need to be careful about the formats and about only outputting one output. You will see how this looks like. We will check this out all in detail. And then if you have a collection, you can create a configuration with tiles in your browser. And the most importantly, you can also make API requests to your collection and then display tiles in, let's say, the images in, let's say, your application or anywhere you would like. So now let's quickly jump back to our agenda. We're now going to create a request using the collection. And as we mentioned, you need to be careful with the formats and with the output. Let's see what we mean. Going to request builder, if I just use the same request as we have for the CRID, and then I click create collection over here and click create, I will get an error. Creation of batch collections with multi-band outputs is not supported. What does this mean? So we have returned an RGB outputs here. So we have a single output which has three different components, an RGB. This is not yet supported in Sentinel Hub for BIOC or for batch collections. This means that over here you need to have one. You need to only be outputting a one request. So what do you do if you actually want an RGB request in your collection? Well, I have the example over here. What you would do in this exact case, you would output three different outputs, named anything you like, but we have named it R, G, and B as red, green, and blue. And then you would also have to add them over here in responses, R, G, and B, so that they are then also reflected in the actual API response. Then in the actual eval script, you just return these outputs are output as samples band 4, green as band 3, and B as band 2. What this is going to do, it is going to process separate outputs. So if we would to now click get low resolution preview, we will get a zip file with three different tips or PNGs, whichever we have selected. If we just quickly extract here, you can see there are 3 different TIFFs, the red one, green, and blue. They are skewed because we forgot to set a keep ratio for the preview, but don't worry, this is only for the preview. So this is what would actually get processed. Now, what you also need to be careful, if you were to set the folder and then the tile name over here, you would get an error because it would get confused because it couldn't put the 3 separate tiles into the same folder like that. So as you can see, invalid tile path, multiple tiles cannot be written to the same output file. So in this case, what you would do, what you would need to do, you would write the name of the folder. You can be anything such as create collection. And then next to the tile name, you would say underscore. And they say output ID dot diff like that. This would then make it possible for you to actually make a collection request. And on your S3 bucket, you would then get all the TIFF files just listed in the same folder. So in the same folder, you would have then, let's say 50 red TIFFs, 50 green, 50 blue, all in the same folder. And you could, of course, also manipulate this exactly so that you would say, no, I actually want all the 3 TIFFs in a separate folder for each tile, or I want all the tiles that are red in the folder for red tiles. You can all do this by reading the documentation and manipulating this path. So if we now click create, this will go through because the path is correct. So this is about the singular outputs. And the other thing that you need to be careful using the collections are the formats. So you need to know that what you're going to process here is exactly the same thing that is actually going to be available to you when you request it using Process API or OGC API. If you say float 32 here, this is the absolute best option because there is not going to be any scaling. The data is just going to be uploaded, processed in the values that the bands are in. But note that float 32, even though it is the simplest option, it will create much larger TIFF files because they're going to be in 32 bits instead of, let's say, 8-bit. However, if we had here, for example, uint8 or auto or uint16 or then some scaling would happen. What would actually happen would be that this would then be scaled to 0 to 255. And when you would be requesting it later, they would still be in 0 to 255. But the script would then expect in your browser or in Process API for the values to be between 0 and 1. And you would then have to divide by 255 to get them back to what the script can understand. So this is something that you have to keep in mind. And we will also see an example like this later, where the scaling happened, and then we had to divide by 255 to get to the visualization. Okay, so let's continue with another example. So the batch processing API is used so that you can process something. This can be a cloudless mosaic, or it can be anything that you can process, and then you can upload it as, for example, as a band that you can use in your scripts, or anything you like. So for this matter, we are going to check a very similar example to this one, but we're going to, instead of outputting RG and B bands, we will be creating NDVI and the moisture index and outputting that. I have the request saved down here. It's this one. I will click parse so that the UI is instantly updated. And as you can see, we have just named the outputs NDVI and NDMI. Up here, we have all the bands that we need to calculate them. We have float 32 so that we don't have any issues with scaling. And then we calculate them normally, and then we just return them. We name the NDVI and NDMI as outputs here, and then reference the calculations here. So this means that the actual NDVI in grayscale and the moisture index in grayscale are going to be uploaded, processed to your bucket and to the collection as 2 different bands. So they're also referenced over here. You need to be careful that you also add it up here. And then when we click process, if we go to, of course, don't forget to create a collection. Each time you want to create a collection, the collection ID that is going to be created is noted down here. And note that cog output has to also be on when you are creating a collection, because it is a requirement. But don't worry, the request builder is going to remind you of that. Let's jump to the configurator to check out our collection. In the configuration utility, if you go to my collections, you will see them all listed here, and you can even filter by BIOC, batch, and TPDI. If we click on batch, you will see our collection, create, NDMI, and NDVI over here. If we click on it, you can see that 2 bands in 32-bit depth were processed, called NDMI and NDVI. These are actually indices in grayscale. So this is the collection ID that we're going to need if we want to create a configuration with new layers. So we should copy that. But you can actually also access it directly from the configuration. And then we already have it set over here, create NDMI and NDVI, with the NDMI already set. So similarly, as we did before with the 120-meter collection, you have to replace the ID. You could copy it here, or you could select it from the drop-down menu. Don't forget to set the collection over here, the collection type to batch, and not leave it as BIOC, because then it is not going to work, because this is in fact a batch collection. Then if for the script, we just used the script from the repository, and we changed the calculation from actually calculating using bands to just calling our band called NDMI. Now let's create another one. Let's jump to the scripts. Go to homepage, Sentinel2, and find the NDVI script. And then I will grab this last one. Back to the configurator, I will create a new layer, name it NDVI. Select bring your own cog and change to batch. And then I will select from the drop-down menu, create NDMI and NDVI. And then in the script, I will just paste it in. But of course, we also need a calculation. So we will just say, let NDVI equals NDVI. Set custom script and save. All right, so now if you go to your browser and refresh, and then go to Discover tab, and then see our create NDMI and NDVI. Of course, we also need to navigate to our create. Check that the time range is matches what you actually ingested. And you can see the NDMI here, and the NDVI layer that we have just created also displayed. Another example that I wanted to quickly show you before we continue with the process API is a cloudless mosaic. If you go back to the request builder, down here in my completed requests, I have the Great Britain cloudless mosaic that I will parse. And as you can see, the whole of Great Britain has been processed with a lot of square kilometers, actually more than 1 million, with Sentinel-2. And as an output, the same as we did before, the separate RGB were returned. However, there is a little trick used over here. The script used was, if we jump quickly to the eval scripts again, Sentinel-2, over here we have the cloudless mosaic script. Cloudless, there it is, the cloudless mosaic. And the cloudless mosaic script, as you can see, has several functions. And the actual cloudless mosaic function actually returns an RGB result. So what we did, we created a new function, evaluate pixel, and renamed this function to cloudless mosaic function. And then we called it in as a variable. Then we used a little trick. So this CM, cloudless mosaic variable, now holds the array of the RGB output of the actual mosaic. And we just call them as red, green, and blue singular outputs by calling the first element of the array, second, and third. So this one, the red is going to correspond to this. The green one is going to correspond to the green channel of the output, and blue to the blue channel of the output. All right, now another thing that I want you to note is that here in this script, uint8 has been used. This means that values are now from 0 to 255. Now we will check this in your browser, and then later when we create a process request, you will see that we will also have to divide. Before that, in the configuration utility, you can also check the configuration that I have made with it, with the true color visualization, R, G, and B divided by 255. So this is literally calling in the outputs of the cloudless mosaic RGB request in red channel, green channel, blue channel as they were processed, and we have to divide them to account for scaling. All right, then in your browser, let's navigate to Great Britain. Let's zoom in a bit, and we go back to search. Great Britain cloudless mosaic. Visualize, and you can see, I will turn off the labels. You can now see the whole Great Britain has been processed, and this has been used with the 60-meter resolution. So sometimes you need to just wait a little bit for it to load, because this is quite a big collection. And if we zoom in, you can see that the resolution is indeed quite good, 60-meter. And then let's just find an interesting location that we would want to use the process API on. Okay, so as you can see, this is a beautiful cloudless mosaic. You can do this yourself. You can do it for the whole continent if you would like. So now what we are going to do, we will create process API and OGC API requests to this collection. And we will just draw the polygon here in your browser of the area that we like. Copy it, jump to request builder, and now this time go to process. Paste in our polygon. You could, of course, also navigate in this window if you wanted to. And now let's redraw it so that it is actually a nice square polygon. You can even go a bit bigger like that. Okay. Over here, we are going to have to select bring your own cog and then select a batch collection. And now we can select it from the drop-down menu, Great Britain Cloudless Mosaic. You can see that the time range has been disabled. This is because it doesn't matter what we set here, because the tiles were processed in a specific time range already. Okay. We now have the default script here, which is not going to be okay. We are actually going to need a script such as that is going to return the bands that we actually have processed. So again, to just repeat, going to my collections, if we check the actual cloudless mosaic collection, we have B, G, and R bands. So we can only operate with this. We cannot say band 2. We have to say B, G, and red, green, and blue in this case. Here we go. Return R, G, and B. So this would now work, but because the values are from 0 to 255, if we would now run this, we would get an image that would not display anything, because the script expect values to be from 0 to 1. So we have to divide this by 255, the same as it was done in the configurator that we visualized in your browser. When we do this and click send, we're going to get an image. And just for the sake of it, let me show you what happens if I did not divide. The image would be overly exposed and too bright. Okay, so now let's also do an OGC request. In OGC, it's similar. You would select an instance, a configuration in this case. So this would be before we were actually selecting the collection, and this time we are selecting a configuration. So this is something that you have to understand is separate. So the collections is over here. So you can make a process request directly to it, but if you want to use OGC, you have to create a configuration with this collection, as we have done using the 120 meter or NDMI and NDVI. All right, so we are going to select the Great Britain cloudless mosaic, and as a layer we only have one, the true color one. And then down here you can also see the request, which we can copy. We can set the PNG, and let's say a larger image of 1000, send a request. And you will get a beautiful image. What you could also do in process and OGC request, you could also set, I want 60 meter resolution, and then you would get the image or TIFF or anything in specifically the resolution that you process the data in. So the full resolution of 60 meters. If I paste the OGC request into the URL, you're going to see the image as well, so that you can embed it into your applications easily. Easily, we could also create a request to our create NDMI and NDVI. Create, let's for example, the NDMI. Of course, we would have to move to create. Let's jump back to height width, PNG, and we get an image displayed. All right, so to sum it up, we have created a request in Request Builder. We also checked how to do it in Python and Postman without a collection. And then we download the data, we stitch them together to create a nice mosaic. We also then created an actual collection, created a configuration to it, and made the process request, OGC request to it, and view them in your browser. Thank you everyone for joining. I hope you enjoyed this webinar. I am looking forward to see any of your interesting collections that you upload to our collections website, or any cool things that you do. Over here you can see the links to our documentation, the request builder, ESA sponsored accounts, and our forum, where you are welcome to ask any questions, and all the links are in the description as well. Thank you again for joining, and I hope I see you at our next webinar. Thank you.